Demeter Principle, or the D in solid, we're making our way through. This one is pretty simple, but also comes with a lot of fun examples. The idea for the Demeter Principle is only talk to your friends, don't talk to strangers. And what do we mean by this is when we start calling methods in a class, is we only want to call methods that belong directly to my class, or perhaps only to instance methods on the class. We don't want to start calling methods on related objects that exist in our class. So this one is really easy to potentially abuse in a language like Ruby. And what we should sort of look for is, let's say in this case, we're working on some sort of payment system where we have the idea of a wallet in our Rotten Potatoes app. And so we might need to do something like, if we have this wallet that maintains a user's balance, maybe we need to check if they have enough money to, redeem that balance for a ticket perhaps, or to buy some popcorn or something like that, whatever it might be. It's really easy to write code like moviegoer.wallet.creditbalance and to start chaining different kinds of methods. You've almost certainly written code that does this. And the question becomes, what happens when that interface changes over time? There's nothing that stops you from preventing long method chains. And so the Demeter Principle is a reminder that these types of method chains are things that we should define concrete interfaces for. So what are some of our solutions? Well, the most common and simple one will be delegating methods. We can separate interfaces by composition. There's a visitor pattern for that. And depending on the type of problem that we're solving, we'll look at the observer pattern, which allows us to define a different kind of class that is essentially looking for changes in the world when something happens. So we'll go through some of these. Delegation is perhaps the most common way to address the law of Demeter. And the law of Demeter is one of the ones where, when we talk about it in the next section, tools are particularly good at helping us spot these violations. So we typically call this as a class having feature envy for another class, which means it is reaching into or calling methods on another class very often. So in our model or in our views, perhaps, or our controllers, if our moviegoer class, it's constantly saying moviegoer.wallet.something, moviegoer.wallet.something, and various other methods, it has feature envy for the wallet class. So we can address this by delegating some of these methods more directly to the wallet class. So we could define a single method, right? Moviegoer.creditbalance. That might help create some boundary between the wallet and the moviegoer. But the better example is actually to think about from a behavior perspective, from not just a code, but what is the task that we're trying to accomplish? Can we define perhaps a better interface? So if we have a wallet class, we might realize that what our wallet class actually needs are methods like deposit and withdraw that define a consistent interface such that what the moviegoer is doing in its implementation is not necessarily trying to directly interact with something like a credit balance, but is trying to accomplish a particular task like adding or withdrawing funds from a wallet. And this is always one of those challenges, right? When we're refactoring, there's two different ways that we can refactor this code. We can insert that seam between two classes, but it's often really helpful if we think about not just how can I separate these two things cleanly, but what is the actual behavior that I'm trying to accomplish? And is there a function that tries to accomplish that? And the law of Demeter is usually a good hint. Perhaps the class that you're interacting with should expose a concrete function that is an interface to that particular task. In this case, withdrawing or depositing money. Another really common pattern that you can see with sort of the law of Demeter is what we can call an observer pattern. And this occurs when we're trying to have changes that need to be captured in a particular class. So the problem statement is that some entity O of an observer wants to know when things happen in some entity S or the subject. And we can think about this as when I do something like update my attributes, am I always calling into some other class to let it know that something has changed? So the way to think about this is if we're acting on certain kind of events, we don't want to pollute our own model to be tied into the fact that every time, let's say, a user gets updated, we might need to fire off some email, or every time a comment is created, right, we need to send some notifications. The observer pattern allows us to, outside of the class, observe changes in one model and hook into when those changes happen to do something like fire off an email as a common pattern, to log some events, perhaps in the case of a security-related task, without directly putting code in our individual class. The other place where we think about observers being useful is that, well, if our task is to do something like fire off a notification email, log something like certain actions that an admin might take that might be a security risk, well, those actions and emails can occur not just perhaps in user class, but maybe in a comment class, maybe in a payments class. An observer pattern allows us to say, across all of the classes, what is the behavior that I'm looking for? Maybe some update on a model, maybe some attributes changing, and have one common interface that exists outside of the class that allows us to look for those changes. There are various hooks that exist in Rails that allow us to implement observers in a few different ways, but the pattern itself is a generic idea of moving that functionality from our subject class to an observer class.